All right, can everyone hear me? Nice. So let's start this. Okay, so first some things about this talk. Uh, how many of you know nothing about music? Okay, please bear with me because you'll probably learn something here. Sorry, guys. So, how many of you know something about music? Okay. How many of you know something about music? Cool. You probably enjoy this talk. And how many of you are like really into music theory? Like, a lot. Okay. Please bear with me because I'm gonna have to make some mistakes to make it more simple. But please bear with me, okay? And well, last thing, I swear to God that this talk has gold. Like, looks like it won't have, but please be patient. And last thing, prepare yourself because we have only 45 minutes, so I'm gonna have to be really fast here. Okay, so first of all, my name is Pedro Maciel. I started design at University of Pernambuco State and then Seneca University. I started my career doing Flash websites. I think a lot of guys too. From Flash, I moved to JavaScript, and to JavaScript, I moved to Ruby. Thanks Rails and thanks Akita. And I worked at small aids agencies, and then I worked on LG, Google. Nowadays, I work in a small startup called Octopi, where we move containers around the world, and I mean like real life containers, not like Docker containers. um, anyway, let's start. So this talk starts on 2013 when a lot was happening in Brazil, and I found at the moment music as means to deal with all the facts that we had to cope with. And I play several instruments like piano, guitar, flute, bass. I learned to play these instruments by myself, and I started taking some. But I bought some gear. I bought like a professional microphone, professional speakers, and started studying mixing or producing, like how to produce a song. Starting to do some experiments, but I wasn't getting the results that I wanted to, and I felt like I needed something more. And the way I found that was like I started thinking music theory classes by Julian Villard on lynda.com, and that completely blew my mind. I just realized that I knew nothing. And well, if I'd ask you to, like, what is the single most quality that you can find in a musician, you probably say that it's like feeling or maybe inspiration, expressivity, and you can see that in the image of Miles Davis. But my favorite jazz man is actually John Coltrane, and it's not like you have to choose one or the other. But John Coltrane, I'd like to think that he's like a developer, like as like a music developer. If he wrote code, he would probably code in C sharp. Okay, bad joke. But so the fact is, to be a musician, you actually have to study a lot, like symbols, syntaxes, patterns, languages. It's not something that is not easy. And John Coltrane went far beyond that. Like, if you look at this drawing at first glimpse, it looks like something like a mystical thing, like maybe a satanist thing. Well, this is a sketch from John Coltrane, and it's really hard for us to understand how powerful the brain of this man was. Like there are tons of mathematical concepts there, and all of them dedicated to music, like a kind of worship to the universe. And let's everyone says that music's pure math, so let's understand how that works. So let's talk about scales, just to make this simple for everyone to understand. So the scales, they are like a group of notes. Okay, so there are some notes you don't choose, some notes you choose. This is a scale, and the scale may immediately resemble musical genre like flamenco or like blues, jazz. And the scale also represents a culture. Like every culture has its scales. Like you have Egyptian scales, Arabian scales. And so let's start with the like C major scale. So the C major scale is like the white notes of the piano, right? So this is an easy example. And as it starts on C, we call the C major scale, right? So that's easy. Now, that's how it sounds. Can you guys hear it? Okay, so that's how it sounds. Uh, okay, very simple. You guys know as Do, Re, Mi, Fa, Sol, La, Si, Do here in Brazil. That's C, D, E, F, G, A, B. Now, if we start the scale on D, look how it sounds. It doesn't sound like a C major scale. It doesn't sound like a major scale. It should sound like a major scale, but it doesn't. Okay, so how is a real... This is a real D major scale. This is how it's supposed to sound. So you'll notice that I play some black notes there. And what is the reason for that? Well, if you look at the piano representation, it's very misleading. It's not a very rational way of describing it. A more rational way to describe it would be like this. Every black note has the same weight of a white note. There's no difference between them intrinsically. And a scale is a pattern of like you choose from C, you jump 2, 2, 1, 2, 2, 2, 1, right? So that what is the pattern of the C major scale. Now, if you go to the D major scale, that's how it looks like, right? Like 2, 2, 1, 2, 2, 2, 1. So you fall into this F sharp and C sharp, and you don't get the C. So if you look in the piano, that's how it looks like in reality. So you can see that, for an very easy example, the major scale gets all crooked up when you just walk one tone ahead. So what about guitar? How does it work on guitar? So this is a presentation of piano again. These are the C major scale, right? The C major scale notes. And what is the guitar then? Well, if you compress that to string, that's what the guitar string is, right? Like this, imagine this is a very weird string, but this is a guitar string and tuned on C. Now, if you duplicate the string 6 times, then you have a very weird guitar, but that's how it would be the C major scale. Now, after you tune that, that's how it becomes. So you can see that music is like very complex. I mean, it's not hard to understand the concepts, but it gets complex very easily. And so thinking about the technology is here to help us to battle this complexity. So what is technology talking about when we talk about music? Well, this is an example project from Google. So as you can see, this is an example where the AI is like to substitute the musician, not to help him, right? So I ask it like, it's cool, but what is the point? What we are trying to look from here? Because AI has never faced what is to be depressed, or never faced addiction, or racism and sexism, or maybe having your nation killed by a genocide that wasn't recognized. So maybe the day that AI gets old enough and mature enough to understand what is to be human, what is to lose people, what is to grow old, maybe their music gets relevant. But in this case, could then still be called human? Like, until then, I feel like AI doing music is like a cool trick. It's something to demo how amazing AI is, but I don't get that as a serious thing for music, in my opinion. So we have another example here of project. So, and here's another example. This one was, so as you saw, it was about like substituting the instruments by digital instruments created by AI. And this is another example, which is actually very nice. It's called Sonic Pi. It's by Sam Arrow, and the guy is very nice. He uses the kids interested by music to teach them how to program. So I really admire this project. But if you look at, for example, a recording like this, so can you imagine any kind of machine doing something as this complex? I mean, when we talk about like this kind of instruments, like a guitar, it's made by real wood, and wood is made by fibers. This is a augmented picture of a wooden guitar, and like the wood is made of fibers. Fiber is made of atoms, molecules, quarks. Like you have dozens and dozens of information there. You also have, for example, this is what a guitar string is when you look very close. So there's a lot of data on real world, and this data is hard to be beaten by by electronic devices. I'm not saying that one is better than the other, just saying that instead of trying to crazily substitute one thing for the other just for the sake of it, we could look into how could bring those things together, right? So after I started having these ideas and studying music theory, had like an idea. um, so I really started like doing like Coltrane did and dove into papers and started doing like very weird drawings and sketches to understand how mathematically things were possible, how things worked, and and here's what I came up with. Like, what if you had some kind of calculator, like something that could extract away the computation, like the boring part of it, but let you, the musician, to compose, and let you, the musician, as to play, like let you play your instrument, but just getting out of the boring part, the math. Okay, so exactly like a calculator does, like you use a calculator, but you have to know the theories and everything. So here's what I came up. Like I started thinking about the problem of C major scale, right? So you have this pattern of 2 2 1, 2 2 2 1, right? So if you look closely to this, and like as a developer, you'll see that this is basically an array, right? So if this is an array, it's an array made of what? It's an array made of intervals, the distance between the nodes. And what are intervals again? Intervals are the distance between two nodes, right? So I started mapping this out, like, okay, I have distance between two nodes, so I have a node entity, and I have like frequency, pitch class, scale, chords, all kinds of things that music theory has. So that's how Coltrane started. So I started to do some scripts to help me on understanding this complexity, and I quickly fell into TDD. I'm not very like big fan of TDD, but it was key to success on this library because I could just say here, like for example, scale, major C, notes names. I wanted to include C, D, E, F, G, A, B. Very easy example, and I didn't. I just went out and did some code. And here's a trick: I not always wrote all tests, but I wrote like the most simple basic test. Then I got the result for the other tests and would counter check that with websites, like for example, ask for major C sharp. I don't know how that is, but let's say what Coltrane tells me. Oh, now let me check that against the website. a music website, and then I just copy paste it into my tests to make them they're more robust. So this is a technique that I learned with the Brazilian. It's like jeitinho brasileiro on testing, and so here was the start of the project, and the initial script experiments, and this is what it became soon, like a lot of entities, a lot of classes, and this is an example on how I used operators to bring the thing of math on this. So for example, we have A plus 2 is a note, but it doesn't have the name, sorry, but it's B, right? Okay, now I have the name. So C plus 2, C sharp plus 2 is D sharp, E plus 2 is F sharp. So I wanted to incorporate the operators to bring out this math of music. And so you can also subtract notes, like for example, C minus 2. And you can also subtract 2 notes and get the interval then, right? So this is the interval class, but if you ask the name of it, like, so A minus C is a minor third. Sorry about you guys that don't know too much about music, but anyways, this is very interesting for who learns about music theory. Yeah. So this is how I started to use CodeTrain. I would boot up a console and play with that, like ask the notes and get my guitar and play together, like code a little, and you can see this is a Ruby console, right? So this is a file where I use the factory pattern to generate other scales as well. So you have like blues scale, harmonic minor, pentatonic, other flamenco, other scales. So, okay, this is nice. You have the notes for example, blues scale on C, and pretty names, but okay, can we have this in a more graphical way? So I said, okay, how the musicians represent music in a more graphical way. And that's what I saw. So no, that's not easy for me. I learned this when I was very young, and I still to date can't read that. It's very difficult. So I said, can I do something different? Something different, and here's what I came up with. So here I'm saving the notes of a major G scale into a variable, right? Then okay, just count. We have 7 notes. That's good because the scale has 7 notes. So I'm instantiating what I call a piano, a representation of a piano. So I'm finding the notes on the piano. I'm saving that into a variable. Okay. And then I get this package and send to a text renderer. And you have to put buts before, and that's a representation of a piano. So that was very difficult, so I wrote a command line terminal interface to make this easier. So I'm using it. Oh, an error. Okay. Right. Yeah. So this is the terminal working. You can do a lot of stuff. Here, for example, I'm looking for scales that have the C, D, and E note. Okay. So the code started to get very convoluted, so I came up with an architecture that was heavily inspired by MVC. So you have commands like find notes, find chords, private chords. I'll explain it later. Find scales. So you send a command to entity objects, which are the theory objects like scale, note, pitch, frequency. Then you have the representation objects like guitar, bass. They are a representation of real instruments, and so it responds something back, and you get this something back, this object, and send to a render. Right now we just have the text render, but I made it in an extensible way so that you can write an image render, for example, and have this as a JPEG output. That's my dream one day. And it responds back to the command sends back to the user. So that's how it works. Okay, so this is an example of the text render. So I have a drawer classes to deal with any kind of data. So for example, if you send an array, that's it will instantiate an array drawer, and the array drawer will take care of rendering an array. What about composing? How can CodeTrain help you on composing? So let's go back to the C major scale, 221, 222, right? And if you look at it closely, each note of the scale has what we call a degree. So have the first degree, second degree, third degree, fourth degree, 5 degree, 6th, and 7th. So each note of the scale is called a degree. So if you pick like the first degree, jump the second, get the third, jump the fourth, get the 5, you have what is called a tertian chord. A tertian chord. So this is a tertian chord, and you can do the same for the second one, right? So second, jump the third, get the 4, 5, 6. So this is another tertian chord. Here's how they sound. Pretty, right? Okay, so so you have 7 different chords because of that, right? And we can call these chords by the number. So I have the first chord, the second chord, the third chord. That's how it goes. So we can talk about music that way. For example, jazz tend to use like first the 2, the first, and the 5th. This is an example for jazz. Like Beatles they used to do like 1-4-5, or is the 50s rock is always 1-4-5. So the most popular, if you get like 1-6-4-5, this is what is called the pop progression, the most popular progression nowadays. The pop progression is used on Despacito, Sia, Offspring, My Chemical Romance, Kelly Clarkson, Scorpions, Simple Plan, Avril Lavigne, Bruce Dickinson, Three Doors Down, Jason Ross, Cranberries, Coldplay, Aerosmith, Coldplay again, Andrea Bocelli, Red Hot Chili Peppers, Green Day, Spice Girls, The Calling, U2. Like the list goes really far away. So yeah, and we're not even including here like the sertanejo. If we include, I would need like 5 of them to make this. Okay, so you can. This is like so predictable that you have this website where if you pick a chord, like a chord progression, it almost like knows which is gonna be the next one. What is the possibility of the next one? Of so repetitive the patterns are. Like basically, if that was a series, it would be house. Like you basically, when he picks the 4th, it basically House saying it's lupus. You know what's gonna come next. So thing is that pop music industry is about making hits. So people they always want to hear like things that they like, and they instantly like things that have the same patterns. So you get like a feedback loop where most songs will follow always the same exact patterns. Like this is just the biggest pattern, but you have other ones, and music will always fall into these patterns. It's very few of them are gonna go on something different. So how can you escape from this trap? Well, that's what John Coltrane was looking for when he was doing these crazy drawings. He was trying to find new patterns, new ways. He was particularly obsessed by the triangle of music and the number 3 and etc. But he's trying to new ways of compose music and push us forward, right? So here's an example of how you can get progressions on Coltrane. So I'm asking here for a pop starting in C. Then these are the chords, and this is just the notes that are on these chords. If you guys don't know, a chord is like when you do this and let it ring, so in a guitar. So these are another example. Oh yeah, so Coltrane can also get the progression for you with a reverse progression search. So this, for example, I went into a very popular Brazilian website and went for this 4 chords, okay, A, M, F, C, and G. You can just write the comment and say A, M, C, F, C, G. And what you see here is that basically other side is almost like a 1-6-4-5. just like 4, 1, 5, 6. It's almost the same. That's why other side is looks like so much with other songs too. So, and I love the other side, by the way. So let's talk a little about modulation, which is another way of bringing freshness into music. So let's go again. 221, 2221. Start, you guys gonna go home and never forget this. Well, how to do a C major scale. So if you look closely at the C major scale, right, and if you look closely at the E major key scales that are almost the same thing, you're gonna see that there are some notes in common. You have the E, A, and B. There are notes that are in common between these two scales. So if they have notes in common, that means, imagine math. You have like one set of possible chords here, another set of possible chords here with the notes that you have. If you bring those two together, the intersection of them are what we call the pivot chords, like chords that can coexist on both keys. You can use that to make songs that start in a tonality and then migrate to the other tonality. And this is like one of major revolutions on music, specifically by jazz. But to do that, you have to remember you have to know every note in every scale, so that you can say, oh, let's go from this scale to the other. Okay, what are the notes on the first one? What are the notes on the other? Like, how can you remember that? I don't know. I never studied music so much. I started studying music like 2 years ago. So the computer helped me here. So how is it do it? Coltrane, common chords between C major and D harmonic minor on piano, and that's it. You have the common chords. So what more do you have here? Okay, so yeah, you can also find scale by, for example, okay, I want to know what is the scale that includes C minor, the chord C minor with seventh and D minor with seventh, and these are the ones. Sorry, let me do it again. C minor 7 and D minor 7. Okay, so if you look here, the intensity of the color is how much notes they really share. So these are the two scales, and the other ones, they have not so much of these notes. Okay, so this is a way of like navigating through the world of music and finding your how you want to do, like to experiment. Like Coltrane is not gonna do your work, is not trying to substitute you. It's just a calculator to help you on this task. So Coltrane nowadays can be found on Ruby gems, and on this is the Ruby Toolbox, just came alive again some time ago. You can find it there, and it's included on Awesome Ruby, along with Sonic Pi, the other project that I told you guys about. And it has many other features that I won't extend here. So nowadays a roadmap for Coltrane is we're wanting to migrate. There's a gem that we use for command line. I want to share with you guys, if you guys want to do a command line application, I use Mercenary, but I'm looking to migrate to Shopify CLI, which looks like very interesting. You can select things and it's very interesting. I want to include chord substitutions, which are something that Coltrane created, John Coltrane himself. I want to have a flute representation, so I can play my flute easily. I want all the other instruments and renderers. Everything is very extensible right now. Circle of fifths. This is something that is very particular to music theory. And a visual app is coming. It's going to be a progressive web app. I tried many different ways of doing a desktop application. Try Shoes, try Ruby Motion, because I'm a Ruby guy and it's hard to do desktop applications in Ruby. So I ended up just let's do a progressive web app, because they're gonna be is there gonna be new trend anyway. It will be live on 2019, I believe. I hope so. It's gonna be live on this domain. I already bought it. You guys can't buy it from me. It's built on Rails. Opal is a Ruby to JavaScript compiler. It gets your Ruby files into really big JavaScripts, but it works really well. So it's fine for me. And Vue.js. My music album, maybe someday. Chinese Democracy went out someday, right? So to know more about, you guys can check on Pedro's slash Coltrane. And that's it. I'd like to end this talk with a quote by Coltrane that I think that applies to our we developers. Yeah, I agree. And some final notes. Gem style Coltrane. That's how I style. You can find me on Twitter slash PedroZaf. You can find Coltrane on github.com/Pedro slash Coltrane. If you want to listen to Joe Coltrane, please search for My Favorite Things, not Neymar, because I hate that song. And thanks.